Ever wondered why some teams automate reports in Excel while you're still copying and pasting data? The difference isn't magic, it's all about understanding Office add-ins. Stay with me while I break down how task panes and content add-ins are just modular web apps and how a few key files can change how you work with Word and Excel forever. Office add-ins, the mini web apps hiding in plain sight. If you've ever opened Excel, wandered over to the ribbon, spotted the Get Add-ins button, clicked out of curiosity, and then just stared at the pop-up window, you're in good company. What exactly am I installing here? A plugin, a program, some hidden Microsoft thing? It's easy to assume there's some deep integration wizardry happening in the background. Actually, most people picture Office add-ins as these mysterious, mystical features built by Microsoft wizards with access to secret APIs. In reality, what's going on is much closer to standard web development than most folks ever suspect. Let's be honest, when you load an add-in, it often pops open on the side, maybe as a task pane, maybe baked into your document, looking almost indistinguishable from a native Office feature. People tap a button, see a new panel, and think it must somehow be tied directly into the core of Excel or Word. But here's the twist. Those add-ins are running as standard web pages right inside Office. That panel, it's a browser window inside your document talking to web services with code written in plain HTML, CSS, and JavaScript. No black magic, no hidden COM objects, just basic web tech that a lot of people already use for internal tools and dashboards. If you've developed even a simple web page, you're more than halfway qualified to build your own Office add-in. The main difference is that you get a few extra tools from Office, special APIs rather than some secret Microsoft handshake. For example, take a look at something like a currency converter task pane. It opens right in Excel, fetches live exchange rates from a public API, updates as you go, and lets you push converted values directly into your open worksheet. It feels like it's part of Excel. But behind the scenes, it's loading up web code, fetch calls, event listeners, front-end frameworks if you want them. HTML and JavaScript are doing all the work. Now, here's where things get even better for anyone who's tired of manual copy-paste rituals. You probably know at least one person who grabs data from an email or a website and pastes it into a spreadsheet all day. Meanwhile, another person down the hall has an add-in pulling that same information automatically, saving hours every week. The only difference is which tools they've got access to. Office add-ins are not reserved for enterprise IT teams or Excel gurus. They're just web apps with a bit of Office flavor mixed in. Another thing that might catch people off guard is how simple updates become once you're using this model. With the old legacy plugins, you might have had to track down installer files, roll out patches, and convince everyone to restart Excel for your fix to land. With an Office add-in, you push a new build to your web server, and next time somebody opens the add-in, they get the latest updates instantly. No packaging executables, no dreaded IT says my plugin broke. Just a straight pipeline from your deployment scripts to the end user's task pane. This approach doesn't just make updates easier, it makes your add-in more portable too. Since everything runs inside what's basically a browser environment, you're not limited to just Windows or that one specific version of Office you've been clinging to since 2016. The same add-in can show up in Word and Excel running on Windows, Mac, and even the browser version through Office for the web. So you're not stuck rewriting code for every platform or explaining why Mac users were left out again. It's one code base that works everywhere Office does. What's interesting is how much flexibility this opens up for business teams once you wrap your head around how it works. Building and deploying an add-in becomes more like working on a web project than wrestling with old school Office plugins. You update files, write code with whatever front-end libraries you like, connect to whatever services you need. The learning curve drops off a cliff once you realize you're simply packaging a web app with a few extra rules. No need to learn arcane macro languages or untangle a mess of legacy code. So when people ask if these add-ins are magic, it's actually more accessible than it looks. When you break it down, it's clear. An Office add-in is just a well-behaved web app with some Office-specific powers. Once you see that, it's not about chasing hidden secrets. It's about using tools you probably already know, just aimed at making Excel or Word less painful for your team. But if these things are just browser-based widgets dressed up as Office features, how do they snap so neatly into the ribbon and know where to show up? What actually makes a basic web app connect to Excel and Word in the right context? That all starts with something surprisingly bland, a simple file that quietly tells Office exactly how, when, and where your add-in should appear. The blueprint, manifest files, and the anatomy of an add-in. If you start poking around the world of Office add-ins, one thing becomes obvious fast. You can't just upload your favorite web app into Excel and expect it to show up in the ribbon. People try, believe me, but Office is pickier than most give it credit for. Behind the scenes, everything hinges on a single XML file called the manifest. Developers love to jump straight into styling their pane or connecting APIs, but the manifest is where the real groundwork happens. You don't see it as an end user, but if anything feels magical about how an add-in slides into the right tab or suddenly appears in both Word and Excel, this is it. Most new devs treat the manifest like a box to check off. Sure, I'll copy one from a sample repo. And then the fun begins. The add-in doesn't load, doesn't appear on the home tab, or just quietly refuses to launch. It's easy to blame Office, but usually it's because the manifest didn't spell things out clearly. The manifest isn't a casual list of links. Office checks this file to read everything about your add-in, where it goes, which platforms it runs on, and when it should even bother showing up. One tiny typo, and it's like you never built your add-in in the first place. You'll notice right away that, unlike most modern web projects, this file isn't in JSON. The manifest sits in XML, which feels a bit retro until you realize how much structure and hierarchy is packed inside. In just a few dozen lines, you'll point Office to your web app location, often a live URL, declare whether this is a task pane, content add-in, or even an Office command, and list every place you want it to be visible. There are IDs for everything, the add-in itself, individual commands, and even specific platforms. Change one of these and suddenly your add-in travels from nowhere to everywhere in the Office UI. The manifest also doubles as your security guard and traffic cop. Here's where you request the permissions you need: reading cell values, editing the document, or accessing external data. Office doesn't just rubber stamp these. If your manifest says you need to edit sheets, you'll get prompted. Miss the permission, though, your code will fail silently, leaving you scratching your head. Let me give you a quick picture of how the manifest shapes everything. Say you want your new tool to trigger from the Excel ribbon and insert a custom chart. That's not handled by your core web code. That's spelled out in this file. You add a command element, wire it to a ribbon button, and point it at your URL. Office sees the instruction, places your button on the Home tab, and tells Excel, when this gets clicked, launch that URL as a task pane and grant it the right permissions. If you want your add-in to work inside a table as a content add-in or even on specific document types, you set those switches right here. Flip a few entries and suddenly your code evolves from a one-trick task pane to a multi-mode tool that pops up wherever your scenario demands. It helps to think of the manifest as a flight plan. Before your add-in takes off and starts running code, Office checks the plan to see where it can land, what airspace it's allowed to use, and which cabin doors it can open. This analogy isn't just for show. If you forget to list a landing zone, say the Insert tab in Word, your add-in never appears there. Get overzealous with permissions, Office flags you, and your add-in can end up grounded for good. Even experienced developers fumble here. More than once, I've seen a change to a manifest's app domain or a mix-up in the URL schema break a deployment nobody can debug for an hour or two. It's a regular initiation right in the Office add-in world. Want another real scenario where the details matter? Picture an add-in that reads a cell range and pushes results to a Power BI dashboard. If the manifest only includes read permissions and skips write access, users might get a beautiful UI but zero results. Or let's say you change the source location property to point at a staging environment without updating all environments. Suddenly, your add-in either won't load or, worse, loads the wrong version for half your user base. Mismatched IDs between manifest and Azure registration, your authentication flow is dead on arrival. And here's a detail that's easy to miss. When Office loads your add-in, the only part it actually checks in advance is the manifest. Your web code, your pretty React components, your CSS, Office doesn't touch them until you pass the manifest test. After that, it's just the browser at work. The upside is, once you nail the manifest, you control everything about how and where your add-in lives inside Office. It's the difference between guessing if your tool will show up and knowing it'll be right where users expect every single time. Of course, the manifest just lays the groundwork. The real fun and the real headaches start when your web code wants to do more than just sit in a side panel. If you want to read or write Excel data, trigger document actions, or actually blend into the workflow, you need something to bridge your web app and Excel. That's where the Office JavaScript API steps in. Office JavaScript API, the conversation between web and Excel. Once the manifest gets your web code loaded, you're staring at what's basically a mini web app parked inside Office. But here's the catch. Just because it's running in a side panel doesn't mean it can reach out and start bossing cells around it. If you ever tried dropping plain old JavaScript into a task pane and expected it to, say, change a few numbers or pull a table, the frustration. Regular JavaScript might move mountains in a website, but in Excel, it hits a brick wall. Office insists on a proper introduction, and that's where the Office JavaScript API steps into the story. This API doesn't work like the loose anything goes vibe you get writing code for a regular browser. The Office JS API gives you a toolkit, but it comes with guardrails and a few learning curves. So you'll see objects called context, workbook, worksheet, and a parade of async methods. That last bit, async, catches a lot of folks off guard. The Office APIs almost always work in an asynchronous way. That means you're not just writing, get me this cell, then do that. You're setting up a chain of commands, sending them to Office, and waiting for Office to hand the results back on its own timeline. Picture this. Your add-in is supposed to grab a sales report table from a user's worksheet, bump up a column by 10%, and then send the new totals to some backend service. You can't just directly poke the DOM for that. With Office.js, you'd call context. Workbook.worksheets, get active worksheet in to target the right sheet, then chain in get range or get used range to scoop up the right cells. Want to see the data? That's another async call. Range, values loaded. You queue everything up, run context. Sync in. And finally, Office reaches into Excel and brings you what you requested. Only then can your code send results off to an API, update a cell, or open a dialog. It's a different rhythm from most front-end web work. There's no quick peek at the DOM, no jQuery style manipulation, just Office taking its measured steps through every request. Even the simple stuff, something like Office context.document, get selected data async, has a specific cadence. This isn't just a fancy way to run document query selector. Instead, you're sending a request to Excel, asking politely for what's been selected, and then writing a callback to actually use that information. The callback is where you pick up the data, check for errors, and finally decide what to do. Get that sequence mixed up, and you'll end up with code that looks fine but accomplishes nothing. Let's talk about one of the top reasons Office add-ins frustrate new devs. Context scoping. With the Excel API, everything needs to happen inside an Excel run function, which hands you a special context object. If you reach for worksheet data without running inside the Excel context, your calls simply vanish. No warnings, no red arrow banners, just silent failures. I've seen more than one experienced web developer pull their hair out here wondering why nothing works. It isn't some obscure bug, just a fundamental rule. Always operate inside that context, always respect the asynchronous chain. Miss it, and your extension turns into a fancy static web page glued to the Excel window. Security is another area where Office draws a hard line. This isn't some open browser session with free reign over the user's machine. Office keeps your web code boxed in. When your manifest asks for permission to edit data, read cell values, or access external services, Office checks it, warns the user, and prevents anything sneaky. Even if you try to get creative with the API, Office limits which data you can touch and when. No silent data leaks, no reaching beyond a user's document session. If you've ever worked with legacy Office automation, you know how scripts could blow past guardrails and drop entire spreadsheets in the wrong folder. Here, Microsoft's drawn the boundaries, and you have to work inside them. One thing that actually makes Office add-in development less painful is this. You get to debug with the browser tools you already know. Crack open Excel, launch your add-in, then hit F12 or open the web inspector. Suddenly you have access to console logs, network traffic, even live editing, just like on a regular website. Old plugin models were basically black boxes. Now you've got every Chrome or Edge dev tool at your fingertips. If something fails, and let's be honest, it will, you can set a breakpoint, check the value of a range, watch your API calls come and go in real time, and iterate without needing to restart Excel every time you fix a typo. If you're coming from web dev, getting fluent with the Office.js API is the step that turns your add-in from a static info panel into a proper workflow booster. You shift from displaying status updates or dashboards that only read data to building real extensions, tools that automate cleanup, run calculations, or kick off routines at the click of a button. Now, if all these APIs and async calls sound a lot like what you've done in web apps before, you're right. Most of the muscle memory transfers over. The main challenge is learning Office's quirks and rules. When you have to request context, how you catch errors, what you can access, and how to chain everything without tripping yourself up. Once you get comfortable, you start to see why modular web-powered add-ins are slowly replacing legacy macros and all those clunky homegrown solutions of the past. But all these technical details matter because they actually change what business teams can accomplish day to day. Let's get into why modular web-powered add-ins are practically a cheat code for teams who want to automate more and copy-paste less. Modularity and skill transfer, why web devs hold the real power. If you know your way around a modern web project, maybe you built a quick React dashboard for your team or messed around with a data visualization in Angular, you're already most of the way to building Office add-ins, whether you realize it or not. That's the part a lot of business professionals miss. There's this long-standing idea that to make Excel or Word do more, you're locked into VBA. Endless rows of macros, or praying someone in IT still knows how to edit those decade-old scripts. But times have changed. The approach today feels more like cloud app development than Office customization from the old days. The Office add-in world runs on web code, modular thinking, and all the standard tooling that's driven every web project since frameworks were cool. We still see it all the time. A department with a reporting process that eats up hours every single month. There's usually that one person who hauls a heap of spreadsheets into Excel, copies numbers from old tabs, tweaks them, stitches them together, and then updates a PowerPoint for leadership. Now, compare that scene with a team who's plugged in an add-in that connects straight to their live data sources, CRM, SQL, web APIs. Instead of sweating over manual updates, they launch the add-in, maybe select a date range or customer group, and the latest data pours right in. Some add-ins trigger workflows, others generate charts, and everything lands exactly where it should. The real magic is that the change isn't powered by heavyweight enterprise systems. It's the same modular code you'd write for a dashboard or web portal, just set to run in the Office context. Let's get specific about what makes this modular approach different. The add-in you build 1 month to visualize sales by product line can 2 months later be dropped into a new scenario with almost no fuss. Maybe your stakeholders want to use a different charting library. Just pull the old NPM package, wire in the new one, and redeploy. Need a different layout for your task pane? Swap out a React component, push the update, and it's live across your fleet. Business users get the change the next time they load Excel. No waiting for IT to push a new installer, no support tickets about versions. That level of flexibility feels more like working on a cloud web app than another lockdown enterprise tool. There's another upside that doesn't get talked about enough, the integration with Microsoft's Power Platform. If your workflow today involves exporting numbers from Excel and uploading them into Power BI, you're doing extra steps. But with a web-powered add-in, you can embed a Power BI report directly or trigger a Power Automate flow based on cell data or user actions. Imagine updating a single row for last month's sales, clicking a button and watching Power Automate move the result through a chain of approvals, notifications, or other apps. Office add-ins aren't just inside Word and Excel, they're a bridge to the rest of your digital workflow, especially if you're already invested in Microsoft 365. The modular component-based structure means you're not tied to a static monolith either. Think about how front-end web teams work. UI in one repo, back-end connectors in another, everyone pushing updates when needed. Office add-ins borrow that same structure. You manage your code with Git, fork a feature branch for a tweak or bug fix, run automated tests, and do code reviews before merging anything live. Deployments move through the same pipelines as your web apps, whether that's Azure, AWS, or behind your company firewall. You keep all the good habits you built working on web projects, no reinvention required. Debugging gets the same treatment. Gone are the days of running trial and error macros and hoping Excel doesn't crash. Launch your add-in, then open dev tools, breakpoints, network monitoring, and real-time editing, all in the browser console you already use. Spot a rendering issue? You can usually patch it, test it, and deploy a fix before anyone ever opens a help desk ticket. If you've ever pushed a hot fix on a Friday afternoon and seen it live for everyone by Monday, you'll appreciate this difference. This way of working also cuts down on a source of pain IT teams know too well: technical debt. When the same skills and tool chains cross over from your web development life, version control, code review, modular deployment, you avoid that deadweight code that comes from generations of spaghetti macros. New business requirements. Build a component, drop it in, and watch it light up inside Office with minimal fuss. It's iterative development, clear ownership, and supportable processes all in one bundle. What's left is a crossover: business power users setting the vision, and web developers powering up the workflow without anyone having to learn a third programming language or chase documentation for VBA quirks. If you approach Office add-ins like just another web app with a few extra rules from the manifest and the Office.js API, it quickly shifts from something mysterious to something you can build, ship, support, and improve in the same way you already do for every other SaaS project. So at the end of the day, what looks like magic from the outside is just solid modern architecture underneath, a convergence of web skills and business needs. No proprietary languages, no closed systems, just smart use of the tools and frameworks that already run half of your internal business apps. This is where Office add-ins stand out, not because they're mystical, but because they finally let you bring tried and true web skills directly into the workflow where they'll make the biggest difference. Which brings us to the big reveal. Is any of this really magic, or just a set of smart connections built on tech that's already everywhere? Let's pull back the curtain one more time and call out what actually makes these add-ins feel so seamless. The reality is, Office add-ins look magical because the architecture is simple and effective. Just modular web apps tied into Word or Excel through the manifest and the Office JavaScript API. If you're comfortable building with HTML, CSS, and JavaScript, you're already set to build real business tools inside Office. The only limits here are what your business needs and what you can imagine automating. Most teams get stuck thinking customization means proprietary tools, but the real story is more accessible. When you start building, it's easy to see what's possible and how much manual overhead you can finally drop.